Hi everyone. I think I probably know most people here. I'm Jim Carosa, and Fran Berman is with us today. And honestly, I can't tell you what uh, a amazing, fun, privilege experience it is to have Fran here and to be able to introduce her. So, uh, Fran and I have known each other for a long time. We worked together on a number of projects in DC and have just known each other in the computer science community for a long time. So I'm going to keep her bio pretty brief here because I could go on for quite a long time about her many distinguished accomplishments and all the amazing things that she's done. But let me give you just a little bit of brief biographical background. So Fran is the Edward P. Hamilton Distinguished Professor of Computer Science at RPI. She's a faculty associate at the Berkman Klein Center for the Internet and Society at Harvard. And I guess a year and a half ago, you were a Catherine Hampson Bessel Fellow at the Radcliffe Institute for Advanced Study.
Oh, Jim, I'm going to interrupt you. Do you know who this year's Catherine Hampson Bessel Fellow is?
I do. It's Li-Shin Gao.
Yes.
From our
from UMass.
From our department.
The tradition continues for computer scientists at Radcliffe.
She's really excited about that. So okay. Fran is many things. She's a data scientist. She's been working most recently on social and environmental impacts of information technology, and in particular on the Internet of Things, which is what she's going to be talking about today. She's focused on data stewardship and preservation longer term. That's tied in with her work on the Research Data Alliance. So I guess that's one of the things that Fran and I have worked the most closely on. The RDA is a community-driven organization. It's like the IETF for data science and research data. I guess that's sort of the way I think about it. Fran really led the international conception and launch of the Research Data Alliance in, 2011, 2012 timeframe. It's now got almost 10,000 members across 130 countries and is working to build data infrastructure for use by groups or research groups and others around the world in research data. She served as co-chair of RDA's Leadership Council, chair of RDA USA for the first 6 years of the organization. And so we work really closely together on that. She's done, if that weren't enough, that's sort of just the beginning. Fran was the VP for research at RPI. Before that, she was director of the San Diego Supercomputer Center at the University of San Diego. She was a professor at UC San Diego and Department of CSE, and the first holder of the High Performance Computing Endowed Chair in the Jacobs School of Engineering at UCSD. Okay, so now I'm not going to go through all your awards, but I will. I'll highlight just a couple of them, if you don't mind. Fran's was the first recipient of the ACM and IEEE Ken Kennedy Award for influential leadership in the design, development, and deployment of national scale cyber infrastructure. So, I mean, Fran just, her work at SDSC and in PACI was just amazing. In 2015, Fran was nominated by President Obama, confirmed by the Senate to become a member of the National Council on the Humanities. She's a fellow of the ACM, of the IEEE, of the AAAS, and she currently serves on as a member of the Board of Trustees for the Sloan Foundation, and again on the National Council for Humanities. She previously served as chair of the Board of Trustees for the Anita Borg Institute for Women in Technology. And maybe with that, I mean, there's a whole lot more, but I think with that, I should probably stop and welcome you here and say how great it is to have you here on our campus. I mean, you are on our campus.
I am. Right? I'm on campus.
So that's great. Many of you know that Fran was, well, not really here on campus, but participating in the symposium for the Computing for the Common Good that the college organized 6 weeks ago or something like that. And she gave an amazing keynote talk there. And we're going to actually reprise that here. So Fran's here live. I'm here live. We're going to ask that people sort of do chat. If you have questions or comments, you can enter them in the chat window, but we're going to replay in a second the talk part of Fran's presentation at the symposium from 6 weeks ago, since it was so well received. She could do it again. We thought that would be a good way to do this. So again, Fran, welcome here on behalf of everybody here. and all the faces that you see
Yay.
out there in Zoom land. Great to have you here.
Thanks. And I'll say, I'm eager to see your questions in the chat, and maybe we'll answer them afterwards, just to make sure everybody's not too distracted by all of the different things going on. I'm really excited to see you all, and I get to meet some of you, which is terrific. And I was really thrilled to be asked to give a talk at the symposium. Because computing for the common good is so the focus of things that really compel me these days, and a lot of what I was doing, and a lot of what I am doing. And so just a word about the talk, I really thought about doing a public interest technology talk, and a talk that talks not just about the technology, but all of the different impacts of the technologies and how complicated and hard it is to really develop technology for the social good. And so the talk is targeted towards specialists and non-specialists, and really for all of us to just really think about what's going on. So without further ado, we'll do the talk, but I just wanted to give you a little bit of an introduction to that.
Oh, I see Leishan's too.
Oh, cool. Congratulations, Leishan. Okay, Alex, I think we're ready. So let's talk today a little bit about the relationship between society and technology. And one of the things I want to talk about is how complex it is to develop technology for the common good. As you might expect, it's a story of kind of rewards and risks and predictable outcomes and unanticipated consequences, twists and turns. And what it demonstrates is that a healthy society needs a synergy. And that's a synergy of technological innovation and social responsibility. So let's get started. So here we are, March 17th, around noon ET, somewhere in the coronaverse, and we are on Zoom. We have spent a year meeting with each other, not knowing if we were wearing shoes, and using the technologies afforded to us by cyberspace to work, to go to school, to order groceries, to have Christmas celebrations with people far away, and to do things that we would not ordinarily have done. In the last year, if not before, these digital technologies have become critical infrastructure. And because of that, we have social responsibility to think about how to best target them. These digital technologies are bringing unimaginable amounts of data. As of last year, there were about 50 zettabytes of data that's sent to the 21st. We expect there to be more than 3 times as much in the next 5 years. Our relationships these days are tech-powered. We interact in person, but lots of times we interact in cyberspace. And an interesting statistic, I think, is that there's almost 7 connected devices for every human on Earth. And if you think about the number of computers and cell phones and Fitbits and smart doorbells and all of the kinds of things that you have in your life, there's a lot of them. And so one of the things to think about is the fact that this technological world we all live in is really driven by the Internet of Things. And if you think about the IoT broadly, it's all of our connected sensors and cameras and computers, our smart systems, our connected baby monitors, our cars, and all kinds of other technologies. The things in the IoT share data. They often work together to make decisions and sometimes operate autonomously in the background. So you might think about, what your personal IoT looks like. Maybe you have a car that connects to the internet and does a number of things autonomously. Maybe you have a Fitbit. Maybe you or a relative or a friend has a connected implantable medical device. Maybe some of your appliances are smart. Maybe your vacuum cleaner figures out the geography of your home and hears from you over your smartphone and can navigate that. Maybe your baby monitor is connected. And so all of these devices, the devices that all of us use every day, um, make decisions, they optimize and they customize and they personalize for us and they make life more efficient. They monitor us and they have smarts. And in fact, the IoT empowers people through these smarts. So they empower people through technology and technology through intelligence. And that gives us both a vision and it also has its downsides as well. Oops. So, where did this come from? And all of us, of course, have been participating in and building these different technologies that came together from the IoT over the last few decades. There have been a huge number of technology advances, artificial intelligence and data science, cloud computing, advances in small scale devices and power solutions, network innovations. But there's also been social drivers. So technology has really become a fundamental platform for social infrastructure. Our businesses these days are data driven and data becomes a real competitive advantage. In the absence of a lot of consumer protections, it's a wild west out there for innovation, and innovation has thrived in a lot of the devices and systems that we use. And of course, the COVID pandemic has made all of these devices more important to our lives and provided sometimes the only way we can connect with each other. And so the IoT has really become really important and it's not going away. So the IoT really underscores the new normal, which is basically ubiquitous critical infrastructure that will drive all of our activities when we go back to on-site, when we go back to each other, and is having a tremendous economic impact. It's changing the economy of all kinds of things, including the surveillance market and the way we live our lives. And so, one question we might have is how do we ensure that the IoT promotes the common good? And there are some pretty wonderful things that have happened as a result of the IoT. We've thought about the rise of robotics in manufacturing, but robotics is also being used by the military in disaster response to go in and save people in toxic environments, or in our surgical rooms, where surgeons can use robotic instruments to perform very precise surgery, whether they're in the same room or hundreds of miles away. If you had an avocado last week, it may have been grown on a smart farm, a place where you can, at the resolution of a single plant, decide how much nitrogen or fertilizer or water the plants need and use a differential approach to watering or fertilizing or maximizing the yield of your field. So there have been a number of incredible innovations and positives that have been brought to us by devices and systems in the Internet of Things. At the same time, we've seen a lot of challenges and a lot of risks from these devices. And you only have to, read the paper every week on a regular basis and see the number of devices that have been hacked or the number of vulnerabilities that have been found in these devices. We've seen people scream at babies and threaten their parents through connected baby monitors. We've seen cyber vulnerabilities in pacemakers that could kill people, and none of them have yet. We've seen a national discussion on facial recognition and mass surveillance, which is becoming more and more prevalent. When is it protective? When is it intrusive? When is it wrong? When does it put people at risk? And so, in some sense, when we think about all of these devices and all of these systems, and we think about promoting the common good, what we really want to do is maximize the benefits and minimize the risks. Now, one of the things that should make us feel a little bit better is, as a people, as a society, we have been here before. And one only needs to look at history to recognize that technology innovation always leads, and then society course corrects. And it's always the case that because we don't have experience with new technologies, we race ahead and we try to figure out what's going on. And then next it comes the social framework and the ethical guidelines. And there was a sociologist by the name of William Ogden that actually introduced this term in the 1920s called cultural lag. So the culture has to really catch up. And you only need to kind of look at the Industrial Revolution to see how important and how important how important that is. Manchester, England, during the Industrial Revolution became an incredibly busy metropolis because of the cotton industry. Before that, in England, cotton had been kind of a cottage industry, and it also had been exports from other places in the world. But during the Industrial Revolution, the rise of factories and the rise on the ability to actually manufacture cotton really made a huge difference. And you only have to kind of look at this really interesting picture and the comment by Alexis de Tocqueville about a thick black smoke covers the city. In the semi-daylight, 300,000 people work ceaselessly. And what really happened during the Industrial Revolution and in Cottonopolis is in those factories, you saw a lot of children and women working. And you saw new pollution that had never been in these areas before. And because of that, in England at that time, you saw some of the first child labor laws. And so that children could do something other than work in these factories essentially 24/7. And you saw some of the first environmental laws. And so, this is a great example of society catching up when innovation has kind of taken us forward. So we can really mitigate the risks and maximize the benefits. And that's what's happening now. Today, in the information age, with all of these digital technologies that have become critical infrastructure, it's really important for us to think about what should we do with these innovations? What are the benefits of them? And how can we make sure that the risks are not catastrophic and that the risks are minimized? And that's sort of part of the job we have when we think about promoting the common good. Now, I think the bottom line from all of this is that we've learned through history and that we need to put it to work now is that how we build and manage the Internet of Things and all of these digital technology matters. And all of the technical architectures that we use, the products and the services and all of these things, they all have societal implications. They impact the environment, they impact society and our protections, they impact the economy, they impact a whole slew of things. And when we do create social controls, they have to be embedded in our technologies. And so if there is a law or a policy about privacy, that might change my access control system or what kind of data I collect and who can use it and how it's used. If there is a new standard with cybersecurity, it might change the kind of architecture I have. I might have to add more firewalls or segment things in particular ways. And as we do that, there are many trade-offs to consider. So you really have to think of all of these impacts that our IoT devices and systems have as a whole universe of things, with many trade-offs between the kinds of common goods we want to see. So today what I'd like to do is not be so general and really talk a little bit about how hard it is and how complicated it is to focus a product and a system in the common good by looking at one of many people's favorite products in the Internet of Things, and that's self-driving cars. So let's spend some time thinking about that amazing beast, the self-driving car. And so the first thing to ask is, how smart is your car? And I will tell you, as one of us who drives probably the dumbest car you can imagine, my car is not smart. And so the Society of Automotive Engineers have actually ranked different cars based on how much human control you need. At the very bottom is cars for which you need complete human control. That would be my 2014 Subaru Impreza. And my car is at the level of 0 or 1. It has anti-lock brakes and it has cruise control, but it needs me, and it needs me all the time. At the highest level is level 5 cars. And that car doesn't exist yet. That's a self-driving car that needs no human intervention at all, and it can drive everywhere at any time. And the everywhere at any time is the part that makes it so far the mythical level 5. For you to buy a car with self-driving capabilities, you're probably buying a car at level 2 or 3. And there's some cars that can do some amazing things. They can park themselves, and they can change lanes, and they can navigate down the highway without your intervention. But they expect you to be around. The industry is now building cars at the levels of 3 and 4. And so those are cars that you see in the ride sharing services, and cars you see for, self-driving trucks that are platooning in California to do that kind of activity. So you see things kind of all across the spectrum. So how do self-driving cars work? And they're also called connected autonomous vehicles. So you'll see me say CAV every once in a while. And a CAV is basically, at least today, what we know is a car with two kinds of components: components that see and components that model and analyze. And these cars drive pretty much the way you and I drive. They sense their environment, they plan what they're going to do, and they act. And they do that all in a fraction of a second, just like we do. And so they have to figure out where they are, where they're going, what all those things are around them, how are they going to get there, and then they have to actuate driving in the car. And so let's just look at the sensors, and the sensors are really fascinating. When you look at a self-driving car, what you find is many redundant kinds of sensors. And these sensors use light, they use radio waves, they use sound waves, they use inertial movement, they use GPS, they use all kinds of things to pretty much figure out what they're dealing with and what they're seeing around them. The reason why they use so many systems is that each system has different benefits and liabilities and ranges and errors. So when you use them in combination, they allow the car to sense their environment in a robust way that minimizes the weaknesses of each particular sensor. And that's really important, because robustness is going to be an incredibly important part of the algorithmic and computational features of these cars. Of course, a video is worth 1,000 words. I guess a video is worth 1,000,000 words. And so let me borrow a little clip from Chris Urmson's TED Talk to show you what a self-driving car actually has to deal with. And as you see, you're on the road, and there's all kinds of things around you. Some things are moving, some things are not moving. You have to anticipate where they're going to be going, at what rate. Some of them are cars, some of them are trucks, some of them are running stoplights, some of them are doing things in unanticipated ways, turning left from the right lane, or jaywalking, or doing all kinds of things. The self-driving car has to anticipate what that thing in the road is. Is that a police person who's looking at traffic and trying to figure out, how to manage people? Is it a pedestrian? Is it a dog in the road? Is it a box? They have to figure out where the construction is and what they might have to drive around. They have to do this in all kinds of driving conditions, and they have to do that whether all of the other objects are doing things they expect for them to do, or things that they don't expect them to do. By comparison, if you think about a self-driving car, it typically has about 100 million lines of code. And by comparison, if you think about an airplane, which has largely autonomous ways of navigating through the air, that has only, the Boeing Dreamliner 787, for example, has only about 6.5 million lines of code. And the fact is, a self-driving car, it's harder to develop the program for a self-driving car than it is for an airplane, because there's so many more things it's likely to come in contact with at much shorter amounts of time, et cetera. And so the fact that we can create self-driving cars that can navigate the road in any way, shape, or form is kind of miraculous. And it's not as if we haven't had accidents. Some of them have been fatal. About a half dozen have been fatal with self-driving cars. But they're getting better and better every year. And the prediction is that by 2050, 2060, all of the cars on the road will be self-driving cars. And we will not be driving anymore. So that's an interesting thing to start thinking about. Now, I want to get back to this notion of impact universe now that we know a little bit of something about self-driving cars, and really think about, as we roam around and look at all of the implications of what these things can do, what about the environmental impacts? And a really key question here is, how do we make self-driving cars sustainable? And so let's think about that a little bit. And typically, we have a number of different strategies that we use for sustainability. One very well-known strategy is to reduce emissions. And there's two ways of doing that. You can do that through the hardware of the car, or you could do that through how the car is driven. In the hardware, there's more and more of a focus on building energy efficient cars. Typically, that means that people are looking at the aerodynamics of the car, but it also means they're looking at whether they're fuel injected or plug-in electric batteries. One of the things you may or may not have seen is that GM just announced that by 2035, all of its cars would be electric cars. And in fact, Ford just announced it's putting a tremendous amount of money between now and 2025 into self-driving cars and energy efficient cars. The software is a really interesting way we can make these cars more efficient. And for those of us who grew up without self-driving cars, that meant good driving. So if you remember, you went to driver training, and in driver's training, they told you, don't ride the brake, don't gun the car, and that's bad driving, but it also increases emissions. And so eco-driving means that we want our self-driving cars to really understand how to smoothly accelerate, smoothly decelerate, not to idle too long, and to do all of those things that are really going to cut the emissions. And developing the algorithms to do that is really useful and really important. We're designing these cars for sustainability. And you really have to think about focusing on the entire automotive life cycle. So for example, you need to think about the emissions when you're actually manufacturing the car. And you need to think about the end of life for the car. And so these days, in a normal, not self-driving car, about 80% of the car is recycled. But now when we have all kinds of extra sensors and computers and cameras on it, we want to make sure that can be recycled or repurposed as well. Today, the amount of e-waste on the planet is mounting at about 50 million tons a year, additional tons a year. And, we see landfills that are now getting filled with, cell phone parts and computers that might be used in cars and other kinds of IoT devices and stuff like that. And that's not a good direction. And so what we want to do is recycle and repurpose as many of the cameras and components from these cars as possible. And it will take some time to figure out the right materials and the right architectures for that. This graph kind of shows you that whatever set of choices you make, you're going to get some trade-offs. And so if you have a car that does well at eco-driving and platooning, so now you're driving smoothly together, very close to one another, algorithms can handle it. You're de-emphasizing performance for sustainability and good driving. Your algorithm is not interested in gunning your car to show off. So this is a good thing. And so we have lots of things like improved crash avoidance. We're making vehicles smaller. We're jettisoning some of the safety equipment and making the materials lighter. That reduces emissions. But that also means that more people will be able to be in cars. And I might use my car for ways that I don't use it now. It means that people who don't drive now can use these cars successfully, children and the elderly and people with disabilities who can't drive. You might use this car to travel a much farther distance because you don't have to drive in the car. You can visit, you can have a meal, you can watch a movie, you can sleep, you can do all kinds of things. So now you might use a self-driving car instead of a plane or a train. And so what we're finding is that some of these things are going to reduce emissions, but some of these things are going to create greater use and they're going to create emissions. And of course, when we have to think about promoting the common good and the development of this, you know, in a way, we have to think about which common good, which of the common goods that we'd like to promote should have priorities. And that's part of the challenge of actually developing these things. One thing that you might find a little surprising is that self-driving cars are really going to change the built environment. And what that means is that if we think about land use and population density and highways and parking and, you know, how often we choose to travel and what we do in cars, all of those will change. This picture of parking is a parking lot that has become standard in New York City. Your car may actually have a higher tier than your apartment. And in fact, about 30% of cities these days in big urban areas is devoted to parking, on-street parking, parking like this, parking underground. And when we have self-driving cars, we may not need this. If the self-driving car is a service, it'll drop you off and go pick somebody else up. If it's your car or it doesn't, or it needs to park, it can park in someplace much farther away than right close to your office. And so we're going to see really a different way to urbanize and a different kind of population density. And that's going to be one of those impacts in the impact universe of self-driving cars. And we're going to have to think about that as we move on. Okay, so let's think about let's roam around some more in the impact universe of self-driving cars and think a little bit about the social effects. And of course, the most important thing for all of us is, and the car manufacturers, is how do we make self-driving cars safe and secure? And so typically, car manufacturers have looked at two ways of making cars safe. Those are passive safety and active safety. In passive safety, you make the hardware of the car safe. You put a bumper on it, or you make it out of certain materials that you think will withstand accidents, or you add seat belts and airbags and other kinds of things. But when we start thinking about connected autonomous vehicles, self-driving cars, those designs are expected to be lighter and smaller a lot of the time. And they are likely to have less safety equipment because we expect those cars, we expect that in general, we will have fewer accidents in those cars. And so we expect them to look different. And some of them might even look like the pods in the Jetsons. People are exploring flying cars and all kinds of things we wouldn't even expect. So in 2050, the roadways are going to look a lot different. But active safety is really going to be the game changer. Active safety is when you make the operation of the car safe. And you and I don't operate that car anymore. The algorithms operate the car. And so how robust those algorithms are, what kinds of errors those algorithms have, you want errors that don't make so much of a difference rather than catastrophic errors. Cybersecurity and all of those will be really important. And of course, there's been a lot of discussion about when cars have to make bad choices. You know, who do you kill? The trolley problem kind of thing. And even though that's a pretty simplistic version of the bad choice problem, it's a problem that's going to face cars. And they're going to have an algorithmic way of dealing with that. And that will challenge us for some time. One of the things that will make those cars more vulnerable rather than less vulnerable is the need for cybersecurity. And if you think about it, a self-driving car is really a computer that drives. And if you think about all the ways that you can attack a computer and all the vulnerabilities a computer has, it's really not something you want to see on the road. You can attack the passwords or the network protocols or have a denial of service attack. Or you can't deal with network outage or the information isn't secure. It can be hijacked. A few years ago, there was a high profile um, demonstration for a journalist who was riding in a Jeep by white hat hackers that basically ran him off the road from several miles away. They got in through the infotainment system and they were able to turn on the radio really high and windshield wipers and basically kind of stop his car while he got it off the road. They were doing that to demonstrate to him just how vulnerable these cars can be, and those fixes got patched, but and he was okay. But you can imagine how difficult these kinds of challenges will be for car manufacturers, because what we don't want, we will not be using self-driving cars if they are not reasonably safe for us. Another thing that we often don't think about is, what about the privacy of you and your car? Other than my cell phone, which comes with me in my car, my Subaru is a pretty safe place. It's not listening to what I'm saying. It's not picking up, for the most part, where I'm going. It's just dumb. And but in these cars with more smarts, a lot of personal data is often collected about you: where you go, where you are, what you're doing, what you listen to, what you're doing with the screen. So that means your phone calls and your texts and your website queries, your favorites of the routes and the stopovers, how you drive, your biometrics, etc. And so one question is, these, and that is not regulated at this point in time, like a lot of other consumer data collected about us. The rights and the ownership of that data is with the car company. And so the question is, what kind of protections do we need to make sure that these cars are going to be safer and that our privacy is protected in these cars? And the car industry has been thinking about that for quite some time. And there's a lot of interesting discussion about the kind of policy and oversight that's needed. It means that we are going to have to think about how we collect, use, and share personal information. Now, note that some of the personal information I give it, it needs for operation. It needs to know where I'm going to go to operate. And so I have to figure out when the car company, or we have to create policy that says when things that we collect for operation are only used for operation, and when we have some control over what's collected otherwise, and how the car company might use it. This also means that when we do have some sort of guidelines and policy about the privacy of personal information in a self-driving car, we need some way of monitoring and enforcing and making accountable those who are collecting the information. So this is really a brave new world, like a lot of this stuff for all of us. And when we think about safety and security and privacy, all of these things make a big difference in terms of the kinds of impacts that self-driving cars will have on our world and on our society. Let me just say that for those of us who are data scientists and computer scientists, there is a wealth of fascinating problems that come from trying to get the technology right and to promote the common good. Decades and years and centuries of work for us to do, and exciting work for us to do, important work for us to do. For those of us studying algorithms, different ways of eco-driving, image classification, feature detection, and all of those things that make us understand what's around us, how they're moving, what to do with them, really important. Robustness and accuracy of these algorithms and ways to minimize catastrophic error is going to be critical. Ethics is a tremendous area, and an area we don't even have our heads around yet in terms of how we develop these algorithms and what's the ethics of these outcomes, what should the ethics be, whose ethics, et cetera. When we think about the system architectures for these algorithms, it means we are trying to think about designing them with cybersecurity in mind, with privacy in mind, and with the computational and power requirements of CAV systems in mind. How much information do I need to send over the internet to other cars in my platoon, or to sensors that are external and otherwise? And there's more. For those of us really interested in computational modeling and simulation, accurate models and parameter estimates are really critical to think about the impacts on the environment, our economic projections, our workforce needs, energy savings, and all manner of things. And of course, in an area that I've spent a long time working in, data stewardship and preservation, cyber infrastructure and use, all of our strategies are really important here. Who collects and who preserves this information? How do we make it available to researchers and to those who need to do analysis? How do we do open science and reproducible research on CAVs? And that's really important because a lot of the data, especially data on level 4 cars, for example, are being collected by private company. And it's their competitive advantage. And so if we want the community to be able to thinking about and using it and doing open science on it, we have to think of good ways for that to happen. So lots of problems for us to work on for sure. And these are just cars. Let me just sort of end our short roam around the impact universe with talking about some economic implications, because, as with other things, these create some of the many trade-offs that we're going to see as well. And let's just look at 3 questions that people often ask. Number one, who will lead the automotive industry? Who will work in the automotive industry? And third, what new jobs and services will be needed? And so let's think a little bit about market leadership. And that might not be something that we typically think about as computer scientists, but it's going to make a tremendous difference in terms of what people do. And if you think about it, there's kind of a struggle right now for market leadership between traditional automotive companies who think of these cars by and large as cars with smart systems, and technology companies who by and large think of these cars as smart systems with driving hardware. And there's a lot of hybrid partnerships in addition. And if you think about it, why that matters is because these industries operate with really different cultures. And in many cases, different laws apply to them. And when we start thinking about the future and the economics of self-driving cars, who leads the market will matter. And how that market evolves matters. And how that market evolves and how that impacts the common good matters. And so market leadership is something to keep our eyes on. One of the things there's been a lot of discussion about is workforce evolution. Not surprisingly, self-driving cars will bring fewer drivers. And so tests in California are showing that if you have trucks and they're platooning along a highway, which is something that most self-driving systems do pretty well on, and then they get to a part where there's some last mile delivery, and often humans, take the ball then. We'll see a lot more of that, especially while we're developing autonomous last mile delivery solutions. The auto industry workforce is going to change too, and we'll see a lot more roboticists and material scientists, computer scientists, engineers than we've seen in the past. And so some jobs are going away and new jobs are happening and other jobs are happening. And businesses will change. And so some of the most interesting changes will come from who actually owns these cars. And now most of us who travel, or many of us anyway, own cars, private ownership. And there's some public transportation and an increasing amount of ride sharing options. But in 2050, 2060, when these cars are ubiquitous, it may actually be mostly ride sharing. If you think about the way we do air travel, there is no public air travel. And very few of us, not me, own our own plane. And so most of us are using a highly regulated private sector industry that keep us in the air. And it may be true that vehicle travel is like that as well. We don't know, but that's one of the things we're thinking about in terms of economic impacts. It means a whole slew of industries that work with automotive dealers and autos will change. Our insurance, rather than having car owner insurance, I might have car renter, something that looks much more like car renter insurance. Auto dealerships and maintenance and repair might work with companies instead of individuals. We'll think about delivery and long haul transportation differently. And we'll see expanded and new uses for CAVs. There might be auto concierge services that host your next party in a CAV, or entertainment services. A sort of chilling possibility in the face of little protections is dynamic surveillance. So think about all those Google Earth cars taking pictures of different people's homes to put on Google Earth. There's no reason we can't have dynamic surveillance services where a self-driving car will roam around and for whatever purposes is needed, surveil people or things or activities. And so, all of these will have social implications, and all of them has implications for the way we think about these, the way we create our laws, the way we create these systems and devices. So this was just a sort of a quick roam through the impact universe of self-driving cars. But of course, this isn't really about cars at all. There's an impact universe of smart refrigerators that will affect us in many ways. Imagine throwing that in the landfill. There's an impact universe of smart insulin pumps where cybersecurity and all of these things make a tremendous difference. And all of these really give us an impact universe of a variety of systems and devices where we're going to have to think really hard and really holistically about how to deal with all the trade-offs to promote the common good. So let me just finish the talk with a ray of hope. Where do we go from here? And as we've seen, Impact Universe has many competing strategies and goals. And we ourselves are going to have to figure out what's most important in various environments and how are we going to balance all of the trade-off. And, one thing that we saw, this kind of gives you just a bit of an example, it might be my goal for the common good to make cars more sustainable. And that's reasonably consistent with making cars lighter. I can make cars lighter. I can make cars out of more sustainable materials. But if I make cars lighter, it may be that all of these right-sized light cars that are traveling in platoons with each other in 2050 really reduce the number of accidents for everyone. But for any given accident we do have, they may be much more severe. The car is light, I'm traveling closely with someone, and it doesn't necessarily make the car safer. Making the car safer would be to build a tank. And so it's not possible to sort of turn all of these dials to max at the same time. We are going to have to make trade-offs, and we need a lot of smart thinking and a lot of thoughtfulness in terms of how we do that. And the good news is that it's not one sector's job. It's not industry, it's not government, it's really all of our jobs. And I have some thoughts about how we might look at that in different sectors just for the next few slides. So in my opinion, the government needs to take the lead in protecting the public. Without oversight, tech can get out of control. Innovation is cool. And we need the social course corrections and controls to be able to make that tech safe and secure and protective of us. That means that, like a lot of bills that are still in committee in Congress, we can legislate consumer protections and personal data protections and various safety and security standards. We can begin to think as a nation about guidelines for ethical development and use and outcomes. And that means not just as an industry, but really as a nation. And we see a lot of that happening in the EU with some of the groups thinking about self-driving cars and other kinds of AI and autonomous systems. One of the things we need is clarity. When something goes wrong, who's responsible? Who's accountable? Who's liable for this? And so we need all kinds of laws that now extend to these IoT devices. Who goes to jail? The programmer, the CEO, is the company fined? What happens? And as Eric Learned Miller said yesterday in the panel we were on, the U.S. government has good a precedent for doing these kinds of things. The FDA, as he pointed out, was developed to protect our food and drugs. If you think about it, OSHA was developed to protect our workplaces. If you work with asbestos, OSHA says that your employer needs to provide equipment that keeps you safe. And so the US government has experience with creating these, you must be at least this tall to ride kind of legislation and agencies. And it's really important for us to have these in the digital world we live in. One of the things that the government can do is regulate the private sector. And when they do, it unleashes a huge amount of innovation, because businesses then can spend time thinking about focusing on public interest focused design, environmentally focused design, and design that really promotes the common good. They can focus more on responsible practice, how we create sustainable supply chains, and explainability of the algorithms, and risk mitigation. And they can focus on transparency about the risks and benefits. If you think about going to the grocery store, we feel like our food is reasonably protected. And we go to the drugstore and we feel that our drugs had to pass muster in some way in order for us to be able to buy them. And, do I feel that good? Do I feel as good about all of the software I use as I do about my apples or my Tylenol? Right now, I don't. And right now, we don't necessarily have the protections we need for all of that. And so one of the things that we can do is really understand when it's safe or not, and have businesses help us by providing that information. As citizens, we often feel kind of overwhelmed by all of this. And understandably, we can't do big things, but we can do some small things that help. We can make informed choices. We cannot buy baby monitors that don't let us change the password. We can protect our personal data. We can use two-phase authentication. Those things are little things we can do, but they'll stop some of the misbehavior, not all of it. And we can promote public responsibility. We can care about this, and we can provide feedback when the government asks for our opinion for something that they're thinking about. There's lots of venues for public opinion. And of course, we've just been through a presidential election. And if you think about the gazillion candidates in the primary, they all had ideas about technology. And when I voted, it was really important to look at my candidate's preferred interest on net neutrality, or on data privacy, or on Internet of Things, or cybersecurity, and all of those kinds of things. So we can do a little bit as consumers. And I think importantly for this group, in higher education, we can do something as well. If you think about it, tech literacy has become the general education requirement for 21st century citizenship and professional work. And as academics, we're trusted parties to build awareness, and particularly awareness about the interplay of society and technology. And one of the things that's happening in universities all around the country is we're starting to see vanguard programs in public interest technology. These are really important programs. They make sure that our students have the knowledge and the experience to be thoughtful citizens and good professionals, and to understand enough about tech to be able to make good decisions, both in their lives now and when they go forward in the future, and to think about the societal strategies that really do promote the common good. And so that's something that we all can do. And I think that's something that universities in particular have a special opportunity on. And with that, I really want to thank you for your attention and for inviting me to talk today.
Okay.
Oh, no. Okay.
Okay. Sorry.
And I did want to tell you that I didn't do that on purpose, but I live downtown in Troy, and every once in a while, a really noisy vehicle comes by, and it just seemed like perfect. So, but I didn't do that on purpose.
So Fran, thanks very much. That was even watching it a second time, it was even better
Oh,
second time.
geez.
And there were lots of great questions and comments in the chat. So maybe actually I guess I can read them to you and then,
That sounds
obviously,
great. Yeah,
uh,
thank you all for listening. I know you're zoomed out after like 1+ years, going on year 2 of
well,
the pandemic.
and the semester's over, but maybe people's batteries are recharging
Let's hope so.
already. So actually, there were a couple of questions I noticed, and a couple of comments along the same theme about um, equity in terms of being able to benefit from the innovations that would happen, and to make sure that the innovations that happen address, you know, address everybody in this country. And so, comments on that?
I know I love all these questions, by the way. It's just like hours of really interesting discussion. And um, when I think about that question in particular, I think we have to draw a contrast between now and, when they're really ubiquitous in 2050. Because I think now, it's sort of a great toy. You can buy a really, really expensive car, many times the cost of my car, and that has all kinds of self-driving capabilities. And most of us cannot drive those. Most of us cannot afford those cars. But I think what we'll find is that these capabilities are trickling down. So now I don't think you can buy a new car without more capabilities than my 2014 car, even a more modestly priced car. And I think, as we go on, that will just be just common for cars to have more and more capabilities. So that's the first thing. And then the second thing is this whole notion of car ownership, which is now almost everyone who's in cars, or many people anyway, have cars. But it's not so clear what the situation will be when these cars are really ubiquitous. Will we treat them like a service? They'll just pick us up when we want. They'll take us to where we want to go. We'll order a car like we order everything else. Will they be like planes? If I want to fly to the West Coast, which I'm going to do next week and see my kids, I don't have my own plane. I go to the airlines and then I deal with the last mile stuff in my own way. But it's a highly regulated private sector space. So I don't have the answer about what the economics are going to be decades from now, but I do think that um, as these things evolve forward, the things that are really expensive and very specialized now um, will kind of migrate to the rest of us, because transportation is critical infrastructure. And you can't have transportation that only a few people can use. And so I do think, market forces will probably in some way, shape, or form have something to do with this. And that again will have to do with will make it more equitable. But now, I think it's not. Whoever asked the question, I would love to hear your views as well.
Right, and maybe I'll say also, I
Okay.
posted this in the chat, but if folks would also like that, I mean, even though we're 70 people, it's probably a small enough group that if people want to ask questions just by raising their hand, I'll monitor that.
Oh, that would be great. Yeah.
And call on people. But while we're waiting for more hands, there are still more questions. So
Okay.
let me go to a question that Narja's had just posted, and it has to do with something I know is near and dear to your heart: data and data use. And this is, I don't know whether it's informed consent or what the exact right term is, but the comment or the question is, gee, when we buy devices, should they come with a sheet that says, here's the data that's going to be gathered, this is how it's going to be used? And I don't know, maybe you could comment a little bit internationally on different views here versus say in the EU with GDPR and things like that.
Oh yeah, I mean, and GDPR is the perfect thing to bring up. And my own personal feeling is, yeah, I think we need to know what kind of privacy we have with all of the devices we use. But that's like necessary but not sufficient. I actually think we should have some control over that. And how you develop the infrastructure to make that make sense, I think, is really a challenge. Do I have to wake up every morning and have 1,000 check boxes about my Fitbit can have my data today, Google Earth
Right.
can have my data, and what happens? Who monitors that? How do we
Right.
do that?
I think it was Lori Craner at CMU who did this study where she said, if you read at 100 words per minute or something like that, how long it would take you to read all of the things that you click through. And it was like 3 weeks of your life would be
Yeah,
spent nothing but reading. So it's not just a question of informing people, but somehow making that in a
right.
digestible way.
And this is where, and I'm a big believer that the only sector whose mission is to oversee and regulate is the public sector, and I think they have to take the lead with that. And I think that there is a lot of thoughts about how much privacy should be regulated. What should we allow companies to do and what should we not allow companies to do? Self-driving car is kind of a good example. You guys might think I love cars, and I actually, love life, but not necessarily cars, or else I'd have a better car. But I do think that these companies, like a self-driving car, has to collect a lot of things about you, but it doesn't have to use those for commercial gain. It could use those to operate the car, and then you might be assured that that information is used perhaps in an accident, perhaps to operate the car, but really not to tell you where to stop for coffee or try to sell things for you or put you at risk if you're doing something in the car that law enforcement is interested in or something like that. So there's all these kinds of very tricky questions, I think, that come together around that. Questions that we haven't solved really for any IoT device, but questions for which the government, I think, is going to have to be a big player in that.
Right. So that's sort of
Oh,
that.
and I forgot GDPR. I'm sorry.
Oh, no, that's okay. Let me, there was another, this was a question that Bev Wolf was asking. When your comments about role of government is sort of intersecting with public policy. For example, when you're talking about public interest technology, obviously lots of disciplines are coming together there. So
Yeah,
public policy, computing, engineering,
right.
um,
Science and technology studies.
right, right. And
Yeah,
so I guess there was a Bev's comment and question was this interdisciplinary, this, when you work across disciplinary boundaries, it's hard. Do you have advice or thoughts about how to make that kind of interdisciplinary collaboration that I think you're calling for here work?
yeah. Let me just detour a little bit on Jim's question for the GDPR, because I did want to
Oh,
point out that government attitude means a lot. And GDPR, while not perfect, while so far from perfect, is a great graduate school try at how you actually try to provide some regulation
we have
that
graduate
supports
students who are
graduate
listening
students.
here.
Yeah.
You meant that as a positive,
No,
right?
that was a positive. That's like as high as you're getting. Um, uh, no, I mean, it's a great try at really how you try to regulate this stuff, but it's also a good example of how complicated it is and how many unanticipated situations there might be. Okay, so back to the question about multidisciplinary stuff. And I'll just tell you a little anecdote from my own past, which is when I was director of the San Diego Supercomputer Center. My absolute best friend on campus was our university librarian, Brian Schottlander. And we were both really interested in data preservation and data stewardship and of those kinds of issues. And of course, we had gear and they had smarts, and we're so used to dealing with the community and collaborating. And then, of course, we all had researchers. And what we found is that when you don't have a common goal and a really clear vocabulary with each other, um, it's hard. You have these different groups that look at each other like different species, right? There are different species I don't understand, but after people worked together for a while and they had some really specific goals and things they wanted to accomplish, it became a more effective collaboration. And I think when you look at these kind of IoT situations, It's absolutely critical to have people who care about the social impacts at the table. And that's lawyers, and that's policymakers, and that's social scientists, and that's all kinds of people. And it's absolutely critical to have technologists at the table too, because we can say we need certain kind of privacy rights and constraints. But unless I can program that into my baby monitor or my smart toaster or, my smart doorbell or any of that kind of stuff, it's not going to happen. And so that's part, I think, of what's challenging. And it's actually part of what I think they did right with GDPR is they brought together a lot of kind of focus group type of consortiums to really hammer out, what happens when we do this? What happens when we make these kinds of rights or we regulate this in some way? What happens in your community? What happens in my community? Is there something we can do that get the outcomes we want and try different strategies? And, I think there's no magic bullet there. I think that's super hard to do. And I think nobody gets that perfectly. And it's stuff that we have to keep trying to do right. But I think if we kind of come into that and we don't have all of those people at the table as real participants, I think it's much, much, much harder. And that's why I think, as wonderful as our community of computer scientists are, we can't do that all by ourselves. We can't, and we really need equal participation from people who are used to thinking about law and policy and rights and all kinds of things.
I think it's also very important that we get down to the issues and the concerns and the needs of the group. But if each group comes in with kind of the end goal, like I want to, like the rules that you're talking about from the European Union, if it's just end rules, some will say yes, some will say no, and the discussion will stop there.
Yeah, yeah. I mean, the other thing is it's sort of interesting because my own view of the EU is that they have done a lot to promote individual rights of their citizens. So when you have discussions about these things, there's kind of a going interest in that. In the US, we have been more positive about rights of companies, and that's really changed the kinds of rules you're likely to see. And, so those sort of fundamental, philosophies, mean that we couldn't take every single thing about GDPR and sort of map it here. I mean, California is a great example because the California digital rights legislation is about as close to GDPR as we come, and some things work and some things don't.
Cool, thanks. And the talk was great. Thank you.
Oh, thank you.
Great. So maybe one last question, and I'm going to ask David Jensen if he wants to just, I don't know if it's clarify or elucidate just a little bit more, but I'm going to read his question and then, so developers will consider systems and data from self-driving cars, for example, to be valuable intellectual property. However, the safety, security, and efficiency of the transportation system is a common good and requires some degree of transparency. Okay, so here's the question. How can the technical infrastructure, as opposed to the regulatory infrastructure, which I think you talked about, be designed to facilitate good choices and outcomes? And I guess, David, I just wanted to ask you if you wanted to say what you meant by the technical infrastructure.
Certainly. So, one of the things I think, one of the challenges we have as technologists and scientists is that it's easy for us to say, oh, that's the regulator's responsibility. We'll let the legislators and regulators do it. And in actuality, they're often faced with what they see as a kind of frozen technology. Here's the technology, we've got to figure out how to regulate it. When actually, there are design choices that could be made really early that could radically alter the regulatory and legislative landscape. And so what I'm asking about is, how do we, in advance of the regulation and legislation, think forward as developers and say, these are likely to be the issues, and to make an infrastructure that's flexible or that's able to manage some of those tensions.
I love that question, and I love your partial answer of it because I would love to bring back the OTA. I would love to hear your thoughts about that, because I think that's where some of those design decisions and ideas could come from, the regulation side of things. But I think you're right. I do think that I think we just go wrong when we say you're going to have to use this kind of technology or that kind of technology, because I think things move too fast. I think we do better, as you said, when we talk about design and we think about outcomes. So whatever systems I use are going to have to give me the right kind of access control and give me the right kind of security and be segmented, right? So I don't have, another pipeline problem or, a hacking problem or something like that. And so, those, if we're specific enough, and please correct me if I'm wrong, David, but I had thought that NIST had done a lot about in particular areas trying to see, and you're shaking your head, so I'd love to see what happened. But in particular areas, I thought they had done a lot towards trying to come to, not necessarily in this one, try to at least specify the kinds of outcomes they wanted. But I do think it's like specification of outcomes, focus on design, because your best products are going to be products that have designed protections in. Let me just say a last thing, because I'd be interested in your comments as well. But a last thing is, I think we still don't know what rights we want. We want privacy. How much privacy? Privacy with respect to what? We want better security. What do we mean by that? We want safety. What do we mean by that? What do we want to do about the relationships that are tech driven, or relationships between us and technology, right? In some sense, what's the Bill of Rights for the information age? And I don't think we know that. And I think we know, when we don't know that, it's particularly hard to design systems and regulate around that. And that, I think, is a really important conversation for us to be saying, for us to be having. I think, for me in the last year, the most top of mind area when it came to that wasn't just privacy, it was face recognition. Where you got all of these things where facial recognition was used to erroneously send people to jail, or it was, people were talking about the bias with people of color and all kinds of things. And so, but I think we have to figure out where we stand as a community on that, to try to then program to that. And that, I think, is a really big problem.
So you mentioned facial recognition, and you mentioned Eric Leonard Miller. The
Yeah.
two of you were on a panel, and we have a live question from him. So take it away.
It's not actually about face recognition, but I mean, you've outlined a lot of great issues here, and I'm also very interested in autonomous driving as a computer vision person, and I'm wondering if you can tell us about some projects or areas that you're interested in getting into, maybe in the next 5 years, or any. I mean, it could be on a high level or a lower level. Like, are you actually going to be working in the autonomous driving area on policy, or thinking about a center, or any way you want to answer that question?
It's a good question. And I will tell you that I did the bulk of my, and continued to do the bulk of my work on self-driving cars when I was a Radcliffe Fellow. And I was highly influenced by the fact that all of the other fellows, almost all of the other fellows, were in different areas. And it just gave me such an interesting, multidisciplinary, broad perspective about all of the things that were going on. It was amazing. For me, it wasn't so much about cars. I think cars are a great example, and they're very accessible. I could have done this talk if I knew much about it, about smart toasters, but I don't think people are as compelled, and they're not really critical infrastructure. And so for me, it's not so much about transportation, but it's about the social aspects of how technology are evolving. It's about figuring out what are our rights, and what does governance look like, and what is the role of all of these different sectors. And, for me, I have to say, these days, I'm incredibly passionate about this notion that all of us in higher education can play a really important role in addressing the simple but incredibly hard question of how can we make technology good for us? And for me, my focus is in really trying to help build the field of public interest technology. And so I'm very interested in, the university is only one participant in all of that. But for public interest technology and this notion that all of the things we do have both a really deep scholarly basis, but they have really real impacts in the real world. And for us to help develop the students, the leaders, the alumni, the community members that can deal with this world in a more effective way, I think is a really important thing for us. So part of what I want to do, a bulk of what I want to do for the next 5 years is really develop public interest technology on a college campus, but also develop the field. Because if you think about it, public interest technology is kind of where data science was about 15, 20 years ago. It's in some really vanguard great places, and they've got some wonderful classes. And a lot of us do research, including me, including you, Eric, that really would come within the umbrella of public interest technology. But if you think about, I wrote a paper on this, and I'm rewriting it right now. And you think about where this stuff gets published. It's not so clear, what conferences, what journals, what practica do our students do? What can we do to give them experiential learning around public interest technology? How can we help our alumni? How can we help the people in our city governments, and our state governments, and our federal governments? So I really think that we could be a real driver, all of us, in building that field and having that field really help technology be better for us. And I really want to spend my next 5 years, my time doing that, because I feel really passionate about it. It's a big, complicated, crazy world, and many things we love about it, but there's many things that are increasingly risky and dangerous for us in it. And if we could make it a little less so, that would be a really good thing to me.
So maybe as your host, I'll take the privilege of asking the last question.
Okay.
The analogy to where data science was 10 or 15 years ago is an interesting one, especially from a university point of view. And I remember the Sloan and the Moore Foundation were sort of seminal in getting things started there. There is a group, right? The Pitt, I forget the foundation.
University Network, yeah.
The University Network, that's funded by a foundation also,
Yes.
right?
They're funded by, and I don't know if I'm supposed to say this, but at least one of you, one of my favorites of you, is actually trying to help UMass become a university member of the Public Interest Technology University Network. So what is that? There's a foundation called New America, which is very interested in social impacts of technology and making the world a better place through technology and a variety of other things. Other ways, they're looking at criminal justice and all kinds of areas. And there are a number of schools who have signed up to be in their university network, and you have to apply and you have to get accepted. And those schools, I think, are distinguished by the fact that they have really taken this seriously. They're developing classes, they're developing practica, they're developing consortium. The New America gives small amounts of money for course development and development of all kinds of stuff. And there's some other foundations that are funding New America to do this as well. But it's a drop in the bucket. And what I'm seeing, and I wonder if you guys are seeing this too, is there's a real hunger for today's students to do things that are socially responsible. And there's a real hunger among our neighbors and our alumni and all kinds of people to do, and us, to do things that are socially responsible. And I think Pitt gives us a mechanism to use our professional assets and capabilities to really contribute in that way. And I think you find that among the universities in the Pitt University Network and beyond. And it would be great to see UMass be part of that as well.
Okay. Well, I think with that, I want to thank you again. It was a
Oh my
wonderful
gosh,
presentation.
thank you
Again, the
guys.
second time through's even better. And thanks for all the conversation afterwards as well. So,
Thanks.
and thanks to everybody for joining in. And I guess we'll see some people around campus and
Yeah,
things like that.
looking
But-
forward to
right.
that.